Hi everyone. So we'll be solving today's problem of the day, that is sum of bit differences. Let us first go through the problem. What is it stating is that given an array integers containing n elements, find the sum of bit differences between all pair of elements in the array. Okay. So bit differences of a pair is the count of different bits at the same position in binary representation of x and y. Okay. So what is the question stating is that we have an array of elements, right? And what we need to do is, first of all, we need to find all of its pair and then find the bit difference between these pairs. Okay, so for example, the bit difference between 2 and 7 is 2. So why? Because the binary representation of 2 is 0 1 0, right? And 7 is 1 1 1. Okay, so the 0th bit is set over here and it is not unset in the case of 2, right? So there is a difference. For the first bit we have 1 1, so that is okay, and for the second bit we have 1 and 0. Again it is set and unset, so there is a difference, so it will be 2. All right. So one of the simplest approach that we get in our minds is that we can just generate all the possible pair of this particular array and then find the bit difference, but that would for sure result in greater complexity, time complexity than O of n. So we need to think of something more efficient than that, right? So let us go through one of the examples that we have, that is 1 and 2. Okay, so the array has 1 comma 2 as input. So what are the possible pair that is being generated? That is 1 comma 1, 1 comma 2, 2 comma 1 and 2 comma 2, right? So if we see in 1 comma 1, the first pair, how many bits are different? Okay, so since both the numbers are same, it will have zero difference, right? Because 0 0 1 is the representation of 1. So if we have both as ones, so the difference would be 0, right? So we'll get 0 over here. Okay, so now next what we have is 1 comma 2 as input. Okay, we have 1 comma 2 as input. So 1 can be represented as 0 0 1, right? And 2 can be represented as 0 1 0. Okay, so in this case how many bits are different? Okay, so let us see the first 0th bit. So here it is set and here it is unset, so we got 1. Okay, now if we see the second bit, that here it is unset and here it is set, so we will again get a 1, that is one more difference is there. And again we will check the third bit, that is same, so we can have a 0. Okay, so in this case we will have two differences, again 2 comma 1 will have two differences and this will have zero differences. So with this we get the total sum of differences as 4. So I hope you're clear with the question at least. So what will be the efficient approach that we will have to find is that, first of all, we need to set a limit to how many numbers or bits that we will be considering. So for integers we can consider at max 32 bits. Okay, for this we'll consider 32 bits, and in this what we'll be doing is we'll go to every ith bit and check the count of ones that are present, right? Or basically the count of set bits that are present, or you can say the count of the bits that are similar. Okay, and what is this n minus count of 1 is that this will give me the number of bits which are unset, right, or zeros. Okay, so if you multiply these two you will get the product of all the type of combination of these pair, and into 2 we are doing. Why? Because here you can see if we are considering 1 comma 2, we are also considering 2 comma 1. So to get all these pair in a single unit and find its sum in a single unit, what we are doing is we are just multiplying it by 2. What basically it means is that we are considering this product two times. Okay, so this is what the approach will be, and so basically this was the logic behind it. What we are doing is we are going to every ith bit and checking the number of ones which are present in this, and multiplying it with number of zeros or unset bit which are present in that particular ith bit, and multiplying it with 2, so that will give me the differences which are formed from this ith position. Okay, the bit differences which can be formed with this ith position. All right, so let's go through the code once. So this is the code, guys. We have first we'll take the result, and what here I'm doing is that we are going through each and every index from 0 to 32 bit. We are having this two variables, which is basically keeping the count of set bits. So after that, we are iterating through all the ith element and checking if it is a set bit. Then we are incrementing this particular sum of set bit variable, and this is basically going to the next ith bit. And here what we are doing is we are find basically this loop is used for iterating through the numbers, right? And this is used for iterating through the bits. So here what we are doing is we are having the ith difference at ith bit is equal to count of set bit, that is number of ones into number of zeros into 2. 2 is basically used for having all the type of combination. So we are considering all the type of combination and adding it to the result and returning the result. So I hope you're clear with this video. Thank you.